Hello everybody and welcome back. We're on to question number 16 now for the 2002 Fermat paper. That's the grade 11 multiple choice contest. And question 16, very short, single line. If AC plus AD plus BC plus BD is equal to 68 and C plus D is equal to 4, what is the value of A plus B plus C plus D? Okay. So we have 4 unknowns, and we only have 2 equations. Now, general rule of thumb, if you're going to be able to solve for every single variable, every single unknown, if we were able to solve for A, B, C, and D, we should expect to see at least the number of equations that we have unknowns. So if we wanted to solve for A, B, C, and D, we should expect to be presented with at least 4 different equations. But we only have 2. Incidentally, seeing 4 equations doesn't mean we'll get all 4, A, B, C, and D, but if we are going to get all 4, we should expect to see 4 equations at least. Okay? So, only seeing 2 equations tells me I'm probably not going to be able to work out the individual value of A, or B, or C, or D. Maybe I can get some of them, but I probably won't be able to get all of them. For example, C plus D is equal to 4. There's lots of different C's and D's that give me that. I don't think I have enough information to narrow down that C has to be 3 or something like that. So, when we do this question, we have to be mindful that we're likely not solving for A or solving for B and then plugging them into this equation here at the end. With that in mind, what do we have in this equation at the end? We have A, we have B, we have C, and we have D, but we don't want to treat them as separate values that we'll have solved for and later plug in. I notice I've got a C plus D. And I have an equation that just gives me C plus D. So I know the last half of the equation, the value that I'm trying to work out, is 4. I know what C plus D is. They gave me that. It doesn't actually matter what C is, because I don't need C. I need C plus D. In the same way, if I could work out what A plus B is, I'd be all set. Now, maybe I can't get A plus B. Maybe I'll have to individually get A or individually get B, things like that. But the tip-off here is we don't have enough equations to get each one singly. So we start to look at groups of them. What could we get? Could we get A plus B plus C plus D as a single expression out of here? Or can we break it down and say, aha, we have C plus D already. Can we just get A plus B? So we've been talking a lot about this C plus D is equal to 4. But what about this big equation right here? AC plus AD plus BC plus BD is equal to 68. Okay. So a couple things go off in my head when I see this. First of all, 68 is 4 times 17. And I have a 4 right here. So is it possible that C plus D is a factor of this expression over here? And if it is, what's the other factor? Could it possibly be A plus B? Well, let's take another read through this, looking out for C's plus D's. I have AC plus AD, or really I have a C plus D, and both of them are times A. Then I have BC plus BD, just a C plus D in disguise times a B. Okay, so let's go to our notepad, and we'll note how we can actually factor this out. Okay. So we have AC plus AD plus BC plus BD, BD, and that's equal to 68. Well, we can take a factor of A out of here. We get A times C plus D plus B. Take a factor of B out. B times C plus D. Well, now I have common factor of C plus D I can take out from both of these. And I realize pretty quickly I get A plus B times C plus D is 68. But I can divide by C plus D, which is 4. And I'm going to be left with A plus B is 68 over 4, which as I already marked is 17. So the thing that I want, a plus b plus c plus d, is really just a plus b plus c plus d. And that's 17 plus 4, and that's 21. Okay, and 21 is D. Right? So, bubble in D, and we're all set for question number 17. Okay, but we'll take a look at that in the next video. So thank you for joining me, and I hope to see you next time.